All right, so here's our lesson on 6.4, prove triangles similar by side, 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 and side angle side. Is either triangle DEF or triangle GHJ similar to triangle ABC? So when we look at these, they actually did a really nice job of color coding these for us already, so we didn't have to do that on our own. If they're not already color coded, what you do is you can choose a different shape for each side of the triangle. So maybe I'm going to use a circle first. So I'm circling the smallest of the three numbers here. The smallest of the three numbers here, I'm going to compare to the smallest of the three numbers here on this next triangle, and the smallest of the third triangle. All right, so how about the middle length of each triangle? 9 is in the middle of 6 and 12, right? And 10 is greater than 8 and less than 16. And then our third one, I'm going to do a diamond. So these are our largest numbers, our greatest lengths on each triangle. So now I know which ones I have to compare or do my proportions to see if the scale factors are congruent amongst all three. So 8 is to 6 reduces to what? What does that reduce to, guys? What goes into both of these numbers? 2 goes into both these numbers, so 4/3. So 4/3, does 12 over 9 reduce to 4/3?
Yes.
3 goes in here 4 times, 3 goes in here 3 times, good. And then our 16 over 12, we need to make sure that that's also 4/3. 4 goes in here 4 times, 4 goes in here 3 times. So we know that these two definitely are similar because they have a 4:3 ratio. Now let's look at this one compared to ABC because they want to know if they're similar to ABC. All right, so 8 over 8. 8 over 8 is going to be 1 to 1. 16 over 16, 1 to 1. 12 over 10 is not 1 to 1. 12 over 10 is going to reduce to 6 over 5. So these two are not similar. So the only one that's similar is going to be DEF. Find the values of x that makes triangle ABC similar to triangle DEF. Okay, so we're going to use the fact that they gave us a similarity statement. Side AB goes with DE, right? AB goes with DE. AB goes with DE. And we are looking for x. X is on BC. BC goes with EF. So we can set up our proportion. We have everything that we need. 4 is to 12. 4 is to 12 as x minus 1 is to 18. All right, so we are going to reduce just to make our math a little bit easier. So this can be 2/6, which is 1/3. And then cross multiply. 4 over 12 is 1/3. 1 times 18 is 18. 3 times x minus 1. Don't forget, you have to distribute. 3x minus 3 equals 18. We're going to add 3 to both sides. (3x) equals 21. Now what do I do? Divide by 3 on both sides, so x equals 7. So x equals 7. The triangles are similar by side, 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 similarity theorem. Which of the 3 triangles are similar? Write a similarity statement. Okay, so we have the smallest, and the smallest, the largest, and the largest, and then the middle numbers. All right, so 20 over 24 would reduce to over 12, which is 5 over 6, right? 5 over 6. 4 goes in here 5 times, 4 goes in here 6 times. 5 over 6. Is this also 5 over 6? No. Right? They're not going to all reduce to 5 over 6. So these two are not similar to each other. How about these two? 20 over 30 is 2 over 3. 24 over 36, is that going to be 2 over 3? 12 goes in there twice. 12 goes in there 3 times. Good. 2 over 3, let's see. 13 goes in there twice. 13 goes in there 3 times. These two are similar to each other. So if this one is similar to this one, but these two are not similar, then those are the only two that are similar. Okay, so those two. So triangle LMN is similar to triangle. So LMN, we went from down the circle over the line. So circle to line. So Y, Z, X. You need to make sure you list them in corresponding positions. Another thing you could do is make angles. So across from the one line, we can make the same. Across from the circle, we can make the same. So 2 marks. And then across from the diamond, we can make 3 marks. And that might help you visualize it a little bit better. So if we were going from LM to N, we're going 1 mark, 3 marks, 2 marks. So 1, 3, 2 would be Y, Z, X. So if that helps you out a little bit with the labeling, use it. They went MLN, that's fine. If they went MLN, they went 3, 1, 2. So we would go 3, 1, 2, Z, Y, X. They must be listed in corresponding positions. The shortest side of the triangle similar to triangle RST is 12 units long. Find the other side lengths of the triangle. All right, so the shortest side of a triangle similar to RST, here's RST, is 12. So we're going to make another one. Which is the shortest side here? 24, good job. So 24 goes with 12. Find the other side lengths. So what goes with 30? If 24 goes with 12, 24 divided by 2 is 12. 30 divided by 2 is 15. Or you could do cross products and solve. You could have done 24 over 12 equals 30 over x, cross products and solve, if you didn't realize that it was just half. Half of 33? 16.5. Fabulous. You are building a lean-to shelter starting from a tree branch as shown. Can you construct the right end so that it is similar to the left end using the angle measure and lengths shown? Okay, so they're saying, are these similar? Well, they both have the 53 degrees. 10 over 15. 10 over 15. So that would reduce to what? 5 goes in here twice, 5 goes in here 3 times. So is this also a 2 to 3 ratio? 3 goes in here twice, 3 goes in here 3 times, right? So 2/3, 2/3. You're building a lean-to shelter. Can you construct the right end that is similar to the left end using the angle measures and lengths shown? So we know that our lengths are proportional. Do you guys see that we have a proportional side, a congruent angle, and a proportional side, and that angle is sandwiched between those two proportional sides? Side, angle, side, similarity. So just like we used to have side, angle, side congruence, now we have side, angle, side similarity. So as long as they have 2 sets of proportional sides with an angle that's congruent sandwiched between them, then we can conclude that they are similar triangles. Tell what method you would use to show that the triangles are similar. So looking at this diagram, what do I know about the angles? Is there any angles that I know are congruent? Yes. B and E. Angles? How do I know about B and E? Nothing's telling me that they're parallel, so I can't go with alternate interior, but there is something that I do know without knowing if they're parallel. Vertical angles. I can mark my vertical angles as congruent. All right, so now, smaller number goes with the smaller number. Larger with larger. 9 over 15. What can I reduce 9 over 15 to? Perfect. 3/5. Good job, guys. 3 goes in here 3 times. 3 goes in here 5 times. Is 18 over 30 also 3/5. 6 goes in here 3 times. 6 goes in here. Perfect. 5 times. 3/5 and 3/5. So we do have 2 sets of proportional sides. So we have side, angle, side. These 2 triangles are similar by side, angle, side, similarity. So we compared the shorter sides. We compared the longer sides. We got the same ratio. Therefore, by side, angle, side, similarity, these 2 triangles are similar. So then you just have to write your similarity statement. Triangle ACB, 1 mark, circle, DCE. They wrote it correctly. Make sure you write them in corresponding positions. Triangle SRT is similar to triangle PNQ. Indicate, okay. So they said SRT, PNQ. So they're drawn in the same positions. So let's compare. 24/18. 24/18. What number goes into both 24 and 18? What number goes into both 24 and 18, guys?
6.
6. Good. 6 goes in here 4 times. And 6 goes in here how many times? 3. So we need a 4:3 ratio. Let's double check that the other ones have the same ratio. 28 and 21. What goes into 28 4 times? 7 goes in there 4 times, and 7 goes in here 3 times. So we have the same 4:3 ratio, so we're good. So by side, angle, side, we know that these 2 are similar triangles. By the side, angle, side similarity theorem. And our last page of this lesson. Explain how to show that the indicated triangles are similar. So we have triangle XZW is similar to triangle YZX. X, Z, W, Y, Z, X. So as I read this statement, I marked it 1 mark, right angle, 2 marks. 1 mark, right angle, 2 marks. Because if it's similar, then their angles are congruent. So that will help me know what goes with what. Although I can also use smallest angle goes with smallest side. So let's try that too. Smallest with smallest. Largest with largest. Middle length with middle length. All right, so 20/15 is going to reduce to what? 5 goes in here 4 times, 5 goes in here 3 times, 4/3. How about our 16/12? 4 goes in here 4 times, 4 goes in here 3 times. And the last one to check is our 12/9. 3 goes in here 4 times, 3 goes in here 3 times. So we know that, yes, we have 3 sides that are all proportional. And so we have that these 2 are similar by side, side, side similarity. Or we could also use side, angle, side. Right? Can we? Let's see. Side, angle, side. Yeah. So you can use both. So it's your choice. Either side, 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 or side, angle, side. Both will completely work because we do have that angle sandwiched between the 2 proportional sides. And that was our entire lesson on 6.4, proving triangles similar by side, 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 and side, angle, side.